Hello and welcome to the example for the surface analysis. Today we're going to be doing a sample from an old case. So first thing we want to do is we want to go to the SPC mesoanalysis page, which is here. You can just search for Storm Prediction Center mesoanalysis and it should pop up. And then we're going to select the region or the sector that we want to focus on. So let's focus on here on the Southern Plains. This gives us the current observations from this time for this area. And if we want to do a current map, we could go to printable surface map in the observations tab. And we could print this out and analyze it. But for this example, what we want to do today is we want to look at an archive one. So we're going to image archive. And the loop, once you hover over loop options, you can pick whatever time you like. So the first thing we need to do is go over and change it to surface observations. So now we get the actual readings from the surface stations. Then we'll go to loop options and we'll scroll down to one that's particularly relevant. And we can use the SPC reports to make sure that we are getting a case where we had some interesting weather for this day. So if we go back, look for something interesting in the Southern Plains region. Here we have some severe weather reports of all types on the 16th, March 16th. So we'll go back, we'll go to the loop options, we'll scroll down to March 16th. And let's just pick something in the afternoon. So let's start with 18Z. Now we're going to get a loop here. What you can do is you can stop the loop, and then all you need to do is right click and open image in this new tab. And once you click on that tab, it shows you whatever image was stopped in that loop. But if you just change the URL, you'll notice the URL has a time at the end, a 4-digit time. In this case, it's 0900 or 0900 for 9Z. So we can just change that to 1800. And this gives us the 1800 surface map. So now we can use this as a way to create our surface analysis. So we're going to copy this image, and we can just do something like this. I'm just doing it digitally for this case, but usually what I would want to do is print it out. But for this example, we're going to open up Paint here, and let's try to get the actual image here. So we'll take a snip of this image, and we'll do all of this, and then we'll copy. Actually, can we just do it? No, we'll copy that, and then we'll put it in Paint here. So Control V. And now what we can do is we can do our contouring and such in a way that makes this an analyzed map. So the first thing we want to do is we want to analyze pressure, which is usually done in black. So we'll do a black solid color with our brush. And the pressure values are going to be here in the upper right hand corner of some of the stations. Notice it's not all the stations. And in this case, it gives it to us just in millibars. So 1007 here, 1002 here, 1002. But in the hourly mesoanalysis maps that I showed at the very beginning, those will be given in a different style, which is explained more in the pressure lesson. It'll give you 3 digits instead of 4 digits, and you'll have to either add a 1 or a 0 in front and then interpret it from there. So in this case, we want to separate the pressure contours by 4 and put them at every number divisible by 4. So we would have a pressure contour at 1,000, 1,004, 1,008, etc. So we've got a station that's under 1,000 here, so we definitely need to have 1,000 pressure contour somewhere in New Mexico. So I'm going to go ahead and draw that. We can draw that. And I'm just kind of guesstimating there's 1,002 here, 1,003 here, 1,002 there. So let's just have something like this as our 1,000 millibar pressure contour. And we would usually want to label these as well. So we might put something like 1,000 millibars. And next we're going to draw the 1,004. So we've got a couple of stations here that are 1,004 exactly. And we just want to have values that are less than 1,004 on one side and more than 1,004 on the other. So we can kind of start up here, and then we'll go right through these stations because they're right at 1,004. That's 1,004. We're going to come around here. We've got 1,003 to the left, 1,006 to the right, and then 1,002, but then 1,007, so we have to come up over here. And that's a pretty good 1,004 contour. And then we're going to do the same thing with 1,008. So we've got 1,008 here, 1,008, 1,007. So we may want to come up and do something like this. And we'll come down here to get this 1,008. Stay to the left of the 1,010. But we've got 1,008 down here, 1,008, 1,009, and a couple 1,008s down here. So we'll call this one 1,008. And the next one we're going to do is 1,012, right? We add 4. So we've got 1,012, 1,012. These are all less than 1,012. We've got 1,012 here. So let's do this. We've got 1,012. And then we've got a couple of 1,011s. So we need to kind of swoop over here. We've got some 1,012s. And then we can come up here. This is 1,014 here. So this is our 1,012. And then the last one we could place is 1,016, but I don't see any stations that high. 1,015, 1,014. Yeah, so I don't see any stations above the next one. These are our pressure contours, black solid lines. And our lowest pressure is here at 1,000. So we're going to put a big L, big red L right there. So we're going to change to a bigger brush. We're going to do L for our low pressure. And then our highest pressure, it's kind of hard to tell, but we've got 1,015 up here, 1,015 down here near New Orleans. Let's just call this our high pressure here. So this is our high pressure. And that's the pressure contours. So now we're going to do the temperature contours. And temperature is going to be every 5 degrees Fahrenheit, and the temperature values are these red numbers in the upper left-hand corner of each station. So we want to put a red line or a red contour between every 5 at every number divisible by 5. So we're going to have one at, like, say, 65, 70, 75, 80, etc. So we definitely are going to have one between right at 70. And we can see that we have some temperatures in southern New Mexico. We've got a 69 and a 72. So we're going to have a 70 line that's going to go right through here. And it's going to come around, there's our 75, so we definitely want to be on the left side of that. And then it'll separate our 70s away from our 60s as we cut through into Oklahoma. We'll kind of have a squiggle there. And then finally into southern Missouri. So, okay, so let's draw that line. So we're going to have, this is going to be our 70 line. So make sure we remember this is 70. We've got the 66 down here. Got a 68. We'll try to loop that one in. Go right through the station at 70. Then we can come down here. Got a 70 down there. 70 here. 70, another 69. So we'll try to loop that one in. A 64 and a 66 for sure. We'll get those in there. And then a 70 here, 70. And we'll come up, and then we'll come up through the high pressure area. So this could be our 70. Let's draw a better 70 here. So we'll do 70. Make sure we label both in so it's not confusing. And we'll put a little F Fahrenheit. So now we want to do a 75 line. So we've got a 76 here in Texas, 77, 82, 79, 78, 77. So we may want to do, we've got this 72 here, so what we may want to do is this. We'll come up here, look at all these temperatures above 75 in this little pocket here. And then we've got 77, but then a 73, and then a 77, 75, 77, 75. It's kind of hard to tell, but 76, 75, 77, 7, and you know, this doesn't have to be exact. We're just trying to get a good idea of what the temperature changes look like for any given area. So all these temperatures are generally greater than 75 to the south and higher than 70 and less than 75 to the north. We can write 75 F. But then we've got this complication here, where we've got cooler temperatures in this area along the Texas coast. So what we can do is we can add another 75 contour to show that it's going now below 75. So we can add another 75 contour sort of here. And this just shows that these temperatures are generally less than 75 again. Okay, and there's even some 80s in here, so we could draw an 80 contour. You know, sometimes if there's just one station kind of out in the middle of nowhere, you know, you could definitely justify drawing like an 80 contour right here, but it's not that important. We could do 80. We could have another 80 contour down in southern Texas. We could have an 80 contour here along the central Gulf Coast. We've got some temperatures above or around 80, so we can have 80. Oh. We can have 80 here. Okay, but I think that's good enough. Let's focus now on our temperatures less than 70. So let's draw our 65 contour. So we've got a 69 here, so we want to be to the left of that, but then we've got much colder temperatures as we go up into like New Mexico and Colorado. Even some temperatures below freezing here, so we're going to be careful with our 65. Definitely between 62 and 69. So we'll have the 65 contour come up here, and then this station 66 will come up here. And we got to be careful not to have our temperature lines cross, because that wouldn't be physical. You wouldn't have a 65 contour come before a 70 contour. So if your 70 contour is this line here, your 65 contour has to always be on one side of it. It can't cross or intersect that line. Now we can have it be very close to that line. That would show we've got a strong change in temperature or a strong temperature gradient. But we never want to have these lines cross each other. So we'll pick up again our 65 line. So we'll go right between these 67 and 64 values. Stay here. We're greater than 61. We want to get this 64 on the right side, but then 68 and 67 need to be on the correct side as well. So 64, and then we've got a 63 and a 64 and a 65. So now we can kind of come up along here, and this can be our 65 contour. 65. And we may want to put the same thing here. 65. Okay, so now we want to draw the 60 contours, 60 degrees Fahrenheit, and these are all 62, 62, 54. So we know there's going to be one that comes kind of through here. We want to get this 55 on the correct side. So our 60, 60, we're trying to map the 60 temperatures here. And we have the 61 here, but then we have temperatures less than that down here. So we'll come down here. There's a 60, we can go right through there. And then finally we can come up through here. So that's our 60 contour. So let's draw 6, 0. And there's not really a lot of space up here, but I can kind of draw a 6 and a 0. And now let's do our 55 contour. So we've got a 54 and a 57, so we know the 55 is going to go right through there. And then we've got a 46 and a 36, so we want to stay to the right side of that for sure. Got a 55, so we can go right through this 55 station. And then I believe that's a 57, so we want to get that on the warm side of there. And there is a 55, so we could put it up here, but then it looks like we've got a 49 and a 47 as we get into Kansas and Missouri. So let's keep that 55 line here. And then we'll have it come right through this station up here. So this is 55. And we'll label the left side as well, 55. Now we're going to draw a 50 line. So we've got a 46 and a 54, so we'll do the 50 line. And we've got a 51, so we'll kind of come up here. And there's even a 50 over here, so make sure to get that sort of on the right side. And then this one for sure kind of comes up here. And then it would come back down over on this side. So we'll have a 50 over there as well. So this is our 50 line. And now we want to do the 45 line. And then once you start getting into these really low temperatures, we know these are at higher elevations, so they're not as important. So let's head to the 45 line as the last line we draw to sort of separate this colder mountainous region from the area of interest, which is going to be the southern plains on this day. So we'll draw a 45 line. The 46 is on the warm side, but 36 is on the cold side. So we kind of need to thread the needle here. And then we'll have this line kind of come up like this. This will be our 45 line. Okay, so those are our temperature contours, and now we want to draw our dew point temperature contours. So we're going to draw these every 10 degrees Fahrenheit on numbers divisible by 10. So 50, 60, 70, etc. And our dew point temperatures are going to be these green numbers in the bottom left-hand corner of each station. So on the hourly mesoanalysis that we showed at the very beginning, they're always going to be in this corner, this region, but they may be black and white instead of green. But these numbers like this 55 and 60 and 59, these are our dew point temperatures. So we want to draw lines which separate out our higher dew points from our lower dew points. So we know, for example, we're going to draw a line at 70 and draw a line at 60. We've got some really low dew point temperatures here in western Texas. We've got a 5, 5, 10, 9, 33. So we know we're going to have a very strong dew point gradient along in western Texas. So let's draw our 60 line first. If we look at the border, 67, 66, 64, 33. So we know the 60 line is going to come down here somewhere. 61, 55, 59, 60. So we may have to loop that 60 in there, but generally the higher moisture of the 60s are going to be sort of on the southern side. So let's start by drawing here. So it's going to be our 60 line. So 60, we'll have 59 on one side, but then kind of loop that 60 in here. We'll come back. We'll draw the 60s on the correct side. We've got a 60 up here. We have to come back down. We've got 63, 62, so we're going to be on the correct side there. And we're going to be off. So we've got 61, 64, and then we've got a 70 here, so we want to make sure that's definitely on the right side. 62, 61. Okay, so this is our 60 degrees Fahrenheit dew point line. And we do have some 70s in there, so we can draw a 70 line as well. And our 70 line is going to hug kind of the coast here. Got 70, 72, 71, 70, 72. And it doesn't have to be perfect. We're just trying to generally understand what the nature of the placement of the moisture air is. So we'll call this one 70. And we could draw one over here too. Just generally, we could have like a 70 line come up and get these higher dew point temperatures. And so there's another 70. Okay, so now let's draw the 50. We know the temperature, the dew point temperature drops off very quickly here in West Texas. So we want to have a 50 kind of over here. 55 would be on the warmer side, or the moisture side in this case. 49 will pass close to the 49. And we kind of just want to eyeball it. Keep the numbers higher than 50 on one side and lower than 50 on the other. We can come up here. There's a 50. We gotta come back down. Okay, so we'll keep that like this. There's a 52, but now here's a 46. I mean, again, we don't want to have our green lines cross. So like what I did over here was probably a bad practice. So just keep in mind that probably would have been a better idea to draw my 60 line something more like that, just to make sure that they don't cross each other. But either way, it's just for practice. So we'll come up here. Here's our 50 line. And it might end something like that. So now we can label this as 50. And we've got to draw a 40 line as well. So again, we've got this 33 here. So let's draw a 40 line. 49. 45. Oh, we got some 40s over here. Make sure we get these in here. And then we've got a 40 over here. So this is going to be our 40 line. That's pretty decent. And then now we want to have a 30 line. So finally we can put a line to the left of this 33 number here. So 30. This will be our 30 line. So separating out higher and lower values than 30, we can go right through this 30 here. And we've got a 35. Oh, we got a 32 down here. And now we've got a 35, so we can come up along here. So that could be our, this could be our 30. Put a 30 down here as well. And now we want to draw a 20 line. So let's do, this would be roughly 10. So maybe it could be better to draw the 10 line first. So let's draw the 10. We're going to come up close to the 9. Here's an 8. We'll go right through this 10, through this, around the 7, and close to this 9. And then here's some single digits here. So we'll cut these off like this. This will be 10. And then we need to draw a 20 line that's between 10 and 30. So we'll draw a 20 line like this. And we need to kind of thread the needle like that. And these are teens, and then there's a 23. So we'll come around like this. There's a 22, 21, 22. So this is roughly where our 20-degree dew point temperature line is going to be. And I don't see any obvious values below 0, so I think that's good enough. So now that we've got our temperature, dew point temperature, and pressure lines labeled, we can start picking out where the fronts are. So we want to draw fronts where we've got a stark change in air mass. So usually that's denoted by a change in winds, and also a change in temperature or a change in dew point temperature. So the one thing that sticks out to me for sure about this day is we've got what's called a dry line, where we have a stark change in dew point temperature, so a change in the amount of moisture here in West Texas, and that's going to be followed along with generally a change in in wind speed as well, or wind direction. So we've got winds coming out of the desert southwest here, and that's converging with winds coming out of the south or southeast and closer to central Texas. So we can draw a dry line generally ahead of where the gradient is. So we can draw, let's make sure our size is right. So we can draw a dry line like this. So this is our dry line. And we may even extend it upwards a little bit. And then we want to figure out if we see any fronts. So we've got a pretty strong temperature gradient up here in Kansas, Missouri, and into Kentucky. And we have some winds, some calm winds here, and then some winds from the south in Oklahoma. And then that ends up running into winds generally from the east over here. So I think we may be able to draw sort of a weak warm front extending along where we have these southerly winds and then up into these temperature gradients here. So if I were to estimate where the warm front would be, I probably would pick something like this. So this is where we've got the most noticeable change in winds that are going to be showing those warming temperatures move upwards or to the north. And then finally we want to draw our cold front. So our cold front is where we have a change in temperatures that are cooling, and we've got the winds that are coming from that direction as well. So it's kind of hard to see on this map, especially with the low over here. I think generally speaking the cold front would be probably further west off this map, or maybe because these winds here in New Mexico are coming from the south, so they would not be bringing colder winds, they'd be bringing warmer winds. So we might have a cold front maybe off the map somewhere. So I won't draw it. There's no obvious cold front here, but we do have a warm front and we do have a dry line. So in this case we're likely to have, depending on other factors, that's kind of important, is to remember that this isn't necessarily going to be how every case pans out depending on the surface analysis. It's also important to understand the upper level dynamics. Do you have shear, adequate moisture, adequate instability throughout the upper levels? So we can highlight our moisture as well. So we can say we've got our stronger moisture. Here's our 70 values. And here's more 70s down here. And we can even do like a little bit of shading for this 60 as well. This is just arbitrary. I just decided that I just wanted some way to quickly show where our higher moisture is, and 60 and 70 tend to be the higher values here on the southern side. So that's why I chose 60 and 70 to highlight here. But you want to highlight something that contrasts the drier air with the colder air, which changes depending on the day and location and the setup. But that's generally the area. I mean, now we can see we've got a lifting mechanism, a strong lifting mechanism in terms of the dry line. We've got a large warm sector here with warm, moist air extending from Texas into Oklahoma and Arkansas. And so I would probably expect our strongest weather to be potentially some discrete supercells firing off the dry line. And then whatever messy convection ends up happening in this warm sector here in Texas and Oklahoma. And if we compare that to our reports from this day, so this is March 16th, that's pretty much exactly what we see. We see widespread severe weather in northern and central Texas, spreading into Oklahoma, and even some localized severe weather in Louisiana, Arkansas, and Mississippi. So that's our example of how to draw a surface analysis. So stay tuned for more lessons, and we'll see you over at weatheracademy.org.